Hello everyone, this is Mr. McMillan. I'm here with some additional examples on angles and arc degrees, um, mainly focusing on kind of a combination of all the different types of angles that we talked about in circles. We'll be working with these for at least a little bit longer, so make sure that you pay close attention to these notes as well as how we determine the answers to each one of these. So for any of these problems, the very first thing you're going to need to make sure you do is figure out what type of angle that you're working with and how that relates to the arcs so that you can most efficiently find your answer. So let's look at number one. It says, what are the measures of angle 1 and angle 2? So you'll see here that we have a vertex. The vertex here is where angle 1 and 2 are. And we have to ask ourselves what type of angle that is in a circle. Well, it's not in the center, so it's not central. It's not on the edge, so it's not inscribed. It is inside the circle, so these would be interior angles. So interior angles are what these would be. So since we have interior angles, we need to have two arcs labeled in order to determine the interior angle that we're looking at. Now, if you remember, we talked about interior angles and how to find them, and we had to take arc plus arc divided by 2. And it didn't matter which arc we listed first because addition is commutative. We can switch them around any way we want to. Now, in this case, the one we can find first would be angle 1. And the reason we can find angle 1 first is because it's the one that's opposite of these arcs. Okay, so angle 1 is opposite of 116, so that indicates that we have to use angle 1 here. So what that means is that angle 1 is going to be equal to our two arcs added together, so 116 plus 71 divided by 2. So that means that 116 plus 71 is 187 divided by 2. That gives us that the measure of angle 1 is equal to 93.5. Now that we have angle 1 to be 93.5 degrees, now we need to use that to find angle 2. Now angle 2 doesn't have any opposite arcs or anything like that, but we can use angle 1 to determine its value. If you look here, angle 1 and angle 2 are on the same line, which means that angles 1 and 2 are supplementary. They add up to 180 degrees. So to find the measure of angle 2, you take 180 and subtract angle 1, which is 93.5, and that gives you 86.5 degrees for angle 2. All right, so let's look at number 2. Number 2 says, what is the value of x in circle T? And x is here, and the vertex this time is on the circle. Okay, so that's on the circle. And we talked about vertices that are on the circle. That would be an inscribed angle. Now, when we talk about the inscribed angle, we need to know its arc before we can find the angle. And the reason for that is because the angle is equal to 1/2 of what the arc is. So let's look in our diagram to see if we can figure out what our arc is. Now, here, angle x, which is right here to here, intercepts this arc here. It intercepts that arc. So if we can determine what that arc is, we can determine what x is. Well, at the center point T, we can see that there's a central angle 162. And remember, your central angle is the same as your arc. So your arc also equals 162. So now to find x, x is our angle. It's equal to 1/2 of the arc. Your arc is 162. So x is equal to 81. Okay. So x is equal to 81. All right, now let's look at number 3. It says in circle S, the measure of arc ARC is 243 degrees. What is the measure of angle ASC? So in this problem, it wants us to figure out the measure of angle ASC. So angle ASC is right here. It's that angle there. So what we know about that angle is that ASC is a central angle. And we know that the central angle is the same as its arc. So if we can determine the arc, we can determine the angle because they have to be the same. Now, in our problem, it says the measure of ARC is 243 degrees. And we know that's a major arc because it's greater than 180. So we start at A, and we go over to the left until we hit R, and then until we hit C. And that is 243 degrees. Now, we want to find arc AC. But to find arc AC, we have to use this 243 degree arc. These two arcs make up the entire circle, and they add up to 360 because that's the total measure of the angles and arcs in a circle. So to find the measure of AC, arc AC, we take 360 and subtract 243. So the measure of AC is equal to 117 degrees. Since angle ASC is a central angle, that means that our angle has to be the same as its arc. So that means that the measure of ASC is the same as AC, which is 117. Okay? All right, number 4. In the circle below, what is the measure of angle SQR? So we want to find the measure of angle SQR. So we go S to Q to R. The middle one is our vertex, so Q is here. And we're also given that QR is 32 degrees. Now, what you may notice is that we have a triangle here inscribed in the circle. And we also know that we have a diameter going across. QS is a diameter. So what we need to do here is figure out, in order to figure out X, we need to know what this arc is. We need to know that regardless of what type of angle it is right now. So we know that Q to R to S, arc QRS, forms a semicircle. So the measure of arc QRS must be equal to 180 degrees. Well, if this whole thing is 180 and we know part of it's 32, then we know the measure of arc RS, which is from here to here, what we want to find, is 180 minus 32 degrees, which is 148 degrees. So this is 148 degrees. Now, if we look at our angle here, we can see that angle Q is on the circle, which means it's an inscribed angle. And an inscribed angle, likely taught before, the angle is half the distance of the arc, or half the measure of the arc. So if our arc is 148, the measure of angle Q would have to be equal to 1/2 of the measure of RS, which is our arc. So the measure of angle Q is 1/2 of 148. So the measure of angle Q must be equal to 74 degrees. All right. Now let's look at number 5. Number 5 says, what is the value of x? So we need to identify what type of angle we're talking about here. And you'll see that this time the vertex is on the outside of the circle. It's nowhere near inside. It's not on the edge, anything like that. The angle we want to find has a vertex outside the circle. So that means that this is an exterior angle. Well, to find an exterior angle, just like we did for interior angles, we need two arcs. We need our bigger one and our smaller one. And unlike the interior angles where we added, we're going to subtract. So we need our big arc minus our small arc divided by 2. Well, in this case, we have the small arc to be 109 degrees. So what we want to determine is this arc here in red. We want to determine this one here. Well, we know that the small arc and the big arc have to equal 360 degrees because they form the entire circle. So to find our big arc, we take 360 minus 109, and that gives us 251 degrees. So we know our big arc is 251, our small arc is 109, and now we just plug those in. So 251 minus 109 all over 2. 251 minus 109 gives you, let me make sure I'm doing this right. 251 minus 109 gives you 142. And then divided by 2, 142 divided by 2 gives you 71 degrees. So the measure or the value of x is equal to 71. All right. Now number 6 is an interesting one. There are a couple different ways to do this, but you know, as with all of these, there are multiple ways that you can approach these. As long as you get the right answer, that's what matters. So in number 6, it says the figure below shows a circle where the measure of angle LRM equals 60 degrees and the measure of angle RLM equals 70 degrees. What is the measure of arc RL? So we're looking for arc RL. We're looking for this arc right here. Now, if you notice, this is a triangle that's inscribed in this circle. So what that means, since we already have 2 of the angles, we can find our third angle, which is angle M, by taking 180 degrees and subtracting 70 and 60 from it, because the sum of the interior angles of a triangle is 180. So when we do that, we find the measure of angle M is equal to 50 degrees. Now we're looking for RL. Now this has 3 arcs and we have 3 angles, so we just need to use the correct angle measure. So here we have, if you look here, you see this arc ends right here and ends right here, which matches up perfectly with angle M. Now angle M is an inscribed angle, so that means that the arc RL has to equal 2 times the angle measure, which means that our arc has to be equal to 2 times 50, which is 100 degrees. Now the reason we could say that is because we know the angle is half of what the arc is. So what number is 50 1/2 of? That would be 100. The other way you could have done this is you didn't have to find 50. You knew that this was, R is an inscribed angle here, so this would be 120, and this would be 140. And if you took these two and subtracted them from 360, you would get 100 there as well. So either way is a valid strategy. All right, so let's look at number 7. Number 7 says, what is the value of x in circle A? And if you look here in your diagram, I apologize for the lights. If you look here in your diagram, you see that you have angle CAB, which is a central angle. And what you need to know about the central angle is that the central angle and its arc are congruent. They're the same. Okay, so what that means is that we can take 4x minus 9, and since the central angle has to be the same as its arc, we set it equal to 51. So we add 9 to both sides, and we find 4x equals 60. Divide both sides by 4, and you get that x is equal to 15. Number 8, it says circle O is given. What is the value of y? Now again, this is another interesting one. You see here that you have two different triangles formed by these intersecting lines. Now what makes this one interesting is the properties we can use to determine what y is. Now if you look here, y is in a triangle. So if we could determine what angle A is, we could easily determine what y is because we know that the triangle has to add up to 180. Well, look here at A. It intercepts with arc DC. It intercepts right there. And if you look on your other triangle, you see that what other angle starts at D, goes to its angle, and then ends at C? Well, that would be DBC. So DBC also intercepts that arc. So angle A and angle B intercept the same arc, so they must be congruent. So that means the measure of angle A has to equal the measure of angle B. So angle A has to equal 38 degrees. Now that you know both of the other angles in the triangle, you can find y. So y is equal to 180 minus 38 degrees minus 64 degrees. And just to make sure I'm doing my math right, you get 78 degrees for y. Okay. All right. So let's flip on over. We got 6 more problems here. So number 9, it says, given the circle below, find the measure of angle MTA. And if you follow MTA, you see your vertex is at T. So you want to find that angle there. Now your vertex is outside the circle. And if your vertex is outside the circle, what type of angle is this? Well, it's an exterior angle, which means we need a big arc and a small arc. And we do big minus small divided by 2. Well, our big arc in this case is 151, and our small arc is 22. So 151 minus 22, and then divide by 2. So 151 minus 22 is 129. Move this out of the way, apologies. 129 divided by 2 gives you 64.5 degrees. All right. Number 10, what is the measure of angle EFG? And if you look at EFG here, EFG is right there. It's that angle. Now you'll notice that angle F is on the circle, so that means that this is an inscribed angle. Now, there are a couple different ways to do this. There is actually a rule for this that we haven't went over, but you can find it using the information that's in the diagram right now anyway. So the 43 degrees is actually very beneficial to us. It is also an inscribed angle, which means the arc it intercepts is equal to double what the angle is. Because the angle is half the arc, so the arc has to be double what the angle is. So it intercepts arc EFG. And if we double 43, we end up with that one being 86 degrees. Now let's look and see how that helps us. If you look at angle EFG, E starts right here, and then it goes all the way around to G, and that's where our arc is for angle X. Well, you should notice that EDG and EFG make up the entire circle. So we know that they have to add up to 360. So we subtract 86 from 360, and we get that our arc there is 274 degrees. Since angle F is also an inscribed angle, we know the measure of angle F has to be equal to 1/2 of the arc, which is 274. So that means the measure of angle F must be equal to 137. All right, number 11. Number 11 says, what is the measure of angle XZY? So angle XZY is here. Remember, it's the middle vertex. And that is an inscribed angle because it's on the edge of the circle. So in order to determine the value of the inscribed angle, you need to know what your arc is. Well, the arc that intercepts with XZY is XY. So we need to know what the measure of XY is. So how are we going to determine that? Well, you should notice that there are two arcs that are labeled here. And when added with that third one, they make up the entire circle. So that means to determine what the measure of arc XY is, we need to take 360 and subtract both of those. So the measure of arc XY is equal to 360 minus 160 minus 172. And when you do that, I believe you get 28, but I just want to make sure. Yes, 28. 28 degrees for our arc. And we know that the angle for an inscribed angle is half of what the arc is. So our angle has to be equal to 1/2 of 28, which means it's 14 degrees. Next up, number 12. Number 12 says, in the circle below, what is the measure of angle DEF? So angle DEF is here. And you'll notice that angle DEF is on the circle, on the edge of the circle. So that means that it is an inscribed angle. Now, since it's an inscribed angle, we know that angle E has to be equal to 1/2 of its arc. Do we already know the arc that's associated with angle DEF? And the answer is yes. Right here, we see that the arc 164 is there. So we know the measure of angle E must be equal to 1/2 of 164. So the measure of angle E is 82 degrees. Last two, both of these want us to solve for X. So number 13, you see that angle CAB here is a central angle, and a central angle and its arc are always the same. They're always equal. So that means that 8x minus 11 must equal 149. We add 11 to both sides and we get 8x equals 160. Divide both sides by 8 and you get that x is equal to 20. And then our last problem here, what is the value of x given the measure of angle XZY is equal to 24 degrees? Now in this case, we see that angle XZY is an inscribed angle. We want to find x and it's on the arc. We already know the angle, and we know that the arc must equal twice what the angle is. So that means our arc must be 2 times 24, which is 48 degrees. Now we know that's 48 degrees, but we still want to find x. So we have to set 3x plus 6 equal to 48. Subtract 6 from both sides and we get 3x is equal to 42. Divide both sides by 3. We get that x is equal to 14. So that's going to do it for this video, guys. I hope these additional example problems do help you out, especially with the assignment that is on the classroom at this point. Please make sure that you are taking notes while you're going along with this. We will go over that other worksheet tomorrow. We just didn't have time to get to it today. There was a little bit of a change of plans. If you have any questions, please feel free to contact me. But in the meantime, I hope this helps, and I will see you guys in the next video.